Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about JFET biasing. So first of all we can compare the symbols of bipolar junction transistor and JFET to understand the difference between these two. So first of all BJT consists of three terminals, base, collector and emitter, in which the collector current depends on the base current. In the JFET, we have drain, source and then gate, in which the current depends on the gate voltage. So the difference is BJT is the current control device, JFET is the voltage control device. And BJT there are current conduction is due to majority and minority carriers. In JFET the current conduction is due to majority carriers only. It has either an N channel or P channel device. So where we apply this JFET is, it is used as an JFET amplifier. So JFET provides the better voltage gain compared to BJT and also high input impedance. So let's see the operating point. So the need for operating point is it is used for bias stability. So to choose the region of operation, and the term biasing indicates the application of DC voltages to establish a fixed level of current and voltage. For transistor amplifiers, the resulting DC current and voltage establish an operating point on the characteristics that define the region that will be employed for amplification of the applied signal. And JFET biasing methods. There are three types of biasing for junction field effect transistor. One is fixed bias, self bias and voltage divider bias. So in this diagram we can see the operating point Q point. First one is the fixed bias. Simplest biasing method, need less components for biasing and cost effective, but the limitation of the fixed bias circuit is not stable. So we can see the diagram of JFET fixed bias circuit. Here the gate terminal is connected to C1 where input signal is given, and it is connected to resistance RG and power supply VGG, and drain terminal is connected to RD and VDD, and C2 coupling capacitor is connected to output V0. So this is the fixed bias amplifier circuit. So here the advantages is it is the simplest circuit. It needs two DC power supply, but the limitation of the circuit is it is poor stable. So we can analyze the fixed bias by applying KVL on the both sides of the circuit. Here for the gate source circuit, minus VGG minus VGS equal to 0. So we get a gate source voltage VGS equal to minus VGG, and drain current ID equal to IDSS into 1 minus VGS divided by VP the whole squared. So this is the general equation for drain current, and drain source voltage VDS equal to VDD minus ID into RD. So next is the self bias, where we eliminate the need for dual power supply and also we use only one power supply VDD, and it is an since it is a voltage control device, we need to bias the gate in the reverse bias condition, and we apply KVL to the gate source circuit. We get VGS minus VRS equal to 0. So VGS equal to minus ID into RS. And also here the term used for pinch of voltage is VP. So drain current is written as IDSS into 1 minus VGS by VP the whole square. So this is the general equation. So in this general equation we substitute the gate source voltage. And next is the voltage divider bias. So circuit is complex, but it is a highly stable circuit and most widely used circuit for amplifiers. So the reason is it provides the higher stability than the fixed bias and the self bias. So we need to analyze the voltage divider bias circuit, we need to use the equivalent circuit. So in this picture, the R1 R2 is connected at the gate. It provides the potential divider, and equivalent circuit is drawn for the voltage divider bias, and gate voltage is given by R2 into VDD divided by R1 plus R2. It is derived using the voltage divider rule. And by applying KVL on both sides, we can derive the voltage and gate to source voltage and also drain to source voltages. So VGS minus VG minus ID into RD equal to 0. So we get the VDS as VDD minus ID into RD plus RS. And drain voltage equation is also applied using the KVL, and source voltage is given by ID into RS. See the assessment, list out the biasing methods for JFET. So what we discussed in the biasing methods are fixed bias, self bias and voltage divider bias, in which the voltage divider bias provides the better stability. Thank you for listening this lecture.